uh, this is the problem with the linear model. So let's see the questions. A population of the beetles is growing according to the linear growth model. Initially there were 4 beetles. So number of beetles at the beginning is 14. So we can write this as time equals to 0, number of beetles equals to 14, we have p equals to 14. Basically this is the 0 comma 14, and we can also think this as x and y, as a time, and y population. So this is the one coordinate, 1 points. And if you look at next, you can see that 10 weeks later there are 47 beetles. So for this is 47, so you can have 47, it's another points. So 2 points, and to find the linear model, we have formula equals to mx plus b. This is called explicit formula, or we p or t as a subscript equals to mt plus b, same thing, because we can see x as a t variable and y as a p variable is the same thing. But here you can see p of t, that's same as y. Okay, so we have a 2 points, and you can call the first point as one as x1 and second point as y2. So if you want to find the slope, you use the formula m equals to y2 minus y1 over x2 minus x1 is the 2-point formula. So y2 here is 47 minus 40 divided by 10 minus 0. Again, this is the formula here, y2 minus y1 over x2 minus x1. This gives you 33 divided by 10, which gives you 3.3. That's the slope. So I need the y-intercept to find the linear equation or linear model. The y-intercept is 14 because the y-intercept is y value when x equals to 0. The initially what's the population, that's going to be y-intercept. So since I have a y-intercept which is 14 and I have a slope 3.3, so you have a function y equals to 3.3 t. We usually put t for x in this context, plus a y-intercept is 14. That's the equation or model. So here write a linear model to describe the number of beetles over the time using week as a unit of time. So the answer is going to be 3.3 t plus 14 has to be the answer. Okay, so next question is, how many beetles are there expected to be 19 weeks after the initial points? So you're looking for how many beetles after 19 weeks. You put t equals to 19 into the model. So basically for this question you put 3.3 times 19 plus 14, and you simplify using calculator. That gives you number of beetles after 19 weeks. That gives you 76.7 beetles. So here it doesn't actually you rounded your numbers, so you can just write 76.7 as a number of beetles after 19 weeks from the initial points. Next question is, when do you expect the number of beetles to reach 75? So you're looking for when do you expect, that's the time. So after how many weeks, that's what you're looking for. After how many weeks, you're looking for number of weeks, like a time. So here 75 is the y value or p of t value. So you put 75 here in the equation, 75 here as a y, and you solve for t. Solve for t, right? That's how you find the time. So 75 here 75 equals 3.3 t plus 14. We subtract 14 both sides of the equation, and you get 25 minus 14 is 61. 61 equals 3.3 t, and divide by 3.3, divide by 3.3, you get. So you get t equals to 8.48 round. So instead of say round it to the nearest week, so this is going to be 18 weeks in this one. So the answer is after 8 weeks. Okay? Thank you.